Hello everyone, this is Chhajed. Today we'll discuss Unit 5 topics multiplexing and multiple access. So these are the content of Unit 5 multiplexing, types of multiplexing, FDM which is frequency division multiplexing, then TDM, time division multiplexing, and these are the two types under TDMs are synchronous and statistical time division multiplexing, and the last one is wavelength division multiplexing. Then timely we'll discuss the FSSS or the spread spectrum, random access, control access, different channelizations. Okay, so we'll start with the multiplexing. So what is multiplexing and what is the need of it? And again, we'll see the two types, FDM and TDMs, and their benefits and drawbacks of each one. So, multiplexing is a technique in which several massive signals are combined into composite signals. Okay, so that this can be transmitted over a common medium or common channels. So, I'll explain you sometimes what happens. The user want to send different types of signals over the same medium or through this common channels. That time the multiplexing will be very helpful because multiplexing will combine this different channels into a composite signals and then it can transmit through this channel. But the issue with this type is what when we transmit these different types of various signal over the same channel, it is essential to keep them apart so that they don't interfere with each other and can be separated easily at the receiving end. Okay, so we'll see this, types of multiplexing, which is analog and this divided into two parts, analog and digital multiplexing. So FDM and WDM is belongs to analog multiplexing, and this time division belongs to digital multiplexing. So we'll discuss the FDM, which is frequency division multiplexing. So in FDM, as the name suggests, the all user use the same common channel or common bandwidth at the same time or a full time, but they are allotted different frequency band to prevent any kind of signal interference, because when the multiple signals sent over the same common channel, then there is a huge chances of signal interferences, and there are different problems occurred in the communication due to the signal interference. So in this FDMs, they having the common bandwidth but divided into different parts. Like the things will be more clear by seeing this example. Like here, if you observe there are four users, and these four users have indicated by the different colors, that the different colors and these bands, like they have divided into different bands. This complete bandwidth is divided into four parts. Each color indicates each type of user and their bandwidth starting and ending times. Like user 1, the starting time is here and the ending time is here. And user 2 starting, sorry, not time, starting band from this to this. User 2 having this to this. User 3 likewise. Okay. So there is a separate bandwidth for each user, but there is no time limit. They can send or they can use this bandwidth for a unlimited time to pass the data or to transmit the data. So same common channel at the same time, all four users can transmit the data at the same time, because each one is belonging to this particular band. So they can send the signals at the same time, and with their bandwidth. So they are not allowed to share the user 1 is not allowed to share the user 2 bandwidth, or like user 2 is not allowed to share user 3 likewise. So bandwidth is divided into multiple users, but there is no time limit. This is what the FDM. So because of this, there is a big chances or possibility of crosstalk in FDM, because of this, because all signals are transmitted simultaneously. So there is a huge chances of crosstalk. So we'll switch to the next is a TDM types, which is time division multiplexing. So in TDM, the complete channel bandwidth is allotted on a one user, which we have what we have seen in this FDM is what there is a this complete bandwidth divided into different bands, and each band is dedicated to one particular users. So whereas in TDM, this complete bandwidth allotted for one user for a fixed time slots. It means each user can use the uh, full bandwidth, but for a fixed time slot, or you can say that its own time slot. So division is based on its time, not on a bandwidth. Like in FDM, division is based on the bandwidth, not in a time. So because of this division type, there is a least chances of, or very zero chances of crosstalk, because at a time only one user are transmitting the signal. So transmitting the signals. So in this diagram, you can see very clearly like user 1, user 2, user 3, user 4, all having their own, colors. Each user is indicated by different colors, and they can use this complete bandwidth for a fixed time slot, whereas in this frequency, they can send parallelly or simultaneously their time band. They are not allowed to send in other time band. Here they can share with they can use this complete bandwidth for a particular time slots. So this is what the basic difference between time division multiplexing and frequency division multiplexing. Hope things are clear at